All right, guys, so in this video, we're going to look at percent composition calculations, okay? So you're probably going to want to have a periodic table and a calculator in order to do these. Now, the main formula that you need to know to find percent composition is pretty simple. It's the mass of the part divided by the mass of the whole thing times 100. Anytime you see mass in a stoichiometry problem, you should probably be thinking periodic table. All right, if I can get my pen to work here. All right, so anytime you see mass, think, I need to use the periodic table, okay? So let's look at the first one. Let's find the percent composition of water. Now, again, in Stoic, we have to be able to name things accurately, okay? And we have to be able to identify their elemental components, right? So obviously, water is an easy one. We know it's H2O, all right? And that means I need to find the mass of the parts. So I have 2 hydrogens. And from the periodic table, I know that the mass of hydrogen is 1.008. And so when I do that, I'm going to get 2.016 grams of hydrogen. Oxygen, I only have 1 of them. And so I'm sitting here with 15.999 grams. I'm going to add those 2 things together. It's something like 18.015. I don't really need a calculator for that. 18.015. Give me just a second here. Let me fix something. That will make that a whole lot better. All right, sorry about that. Anyway, so now this is the mass of the whole thing right here, 18.015 grams. So I have my parts, I have the whole. So I'm going to take this, if I get my mouse to work here, there we go, 2.016 divided by 18.015 times 100 is going to give me my percent hydrogen, and 15.999, the part, divided by 18.015 times 100 will give us our percent oxygen. So we'll run those numbers. So 2.016 divided by 18.015 times 100 is 11.19% hydrogen. That would be my answer for that. And 15.999 divided by 18.015 times 100 is 88.81% oxygen. Now, here's the cool thing about percent composition. You should never, ever, ever get one of these wrong, because these 2 numbers have to add up to 100%. If they don't add up to 100%, you know something's wrong. Now, if you add them up and you get like 99.4, okay, you have a little rounding issue, not a big deal. Anything outside of 99 or 101, though, you need to look a little closer, okay? So there's our 2 answers. Let's do another one. The percent composition of carbon dioxide. Again, I have to be able to take a name and write a formula. From my periodic table, I know that carbon is 12.011 grams per mole. I only have 1 of them, so that's all I need. Oxygen is 2 times 15.999, so that's 31.998. 31.998 plus 12.011 gives me a whole mass of 44.009. There we go. Grams per mole for CO2. So there's the whole thing. So again, 12.011 divided by 44.009 times 100. 12.011 divided by 44.009 times 100 gives me 27.29% carbon. Now, let's be smart. We know they have to add up to 100. We know we only have oxygen left, so we could just say 100 minus that answer is going to be the percent oxygen, which would tell us 72.71% oxygen. I just did 100 minus that number right there. Well, let's go ahead and just work it out to make sure we're right. 31.998, because you can do it either way. 44.009 times 100. 31.998. And we get 72.707. That's pretty good. Again, we're going to box in our answer. And that is the percent composition of CO2. Now, this question, I'm going to make myself a little smaller there. This asks us to find the percent composition of carbon in glucose. So we know glucose, it's C6H12O6. Hopefully you remember that from biology. All we need is the carbon. So we don't need to find the mass, or we don't need to do the math. We don't need to do the math for all of the parts. We just need to find out what the whole thing weighs and then what carbon's percentage is. So let's set this thing up. We can say that 6 times 12.011, because there's carbon, plus 12, 1.008, and that's hydrogen, plus 6, 15.999, that's oxygen. Something like 180. 12, 1.008 plus 6, 15.999. Be 180.156. There's the mass of the whole. All right, so now we're just going to say 6 times 12.011 over 180.156 times 100. And that's going to give us carbon. So 6 times 12.011 divided by 180.156 times 100 is 40.00% carbon. Now, because the question only asked me to find carbon, that's where I stop. That would be my answer. I don't want to do the rest of them and box them in. They would be incorrect. All right, let's do one more. We have ammonium sulfates. This is really testing your ability to name things, right? So ammonium, we know, is NH4 plus 1. Sulfate is SO4 minus 2. So when we cross those charges, we're going to get NH4, 2, SO4. There is our compound. And we want to know how much or what the percentage by mass of hydrogen is in this. So this is very similar to the other question where we're just looking for one specific compound. So let's do that. So we have 2 nitrogens at 14.007 each. I just distributed the 2. Plus 8 hydrogens at 1.008 each. Plus 1 sulfur. And sulfur I'll have to look up because I don't know it. Let's find the periodic table here. 32.065. I'll just have one of them. 065 plus 4 times 15.999 for oxygen. All right, so we put that in our calculator. And we get 132.139 grams per mole for the whole thing. We just need hydrogen. So 8 times 1 is 8. 8 times 8 is 64. So 8.064 over 132.139 times 100 equals our percentage. 6.10% hydrogen. All right. So there we go. Part over whole times 100 is how you do percent composition. Pay attention to the question. If it just asks you to find one specific element, then only find the one, right? Don't waste your time doing the extra. Move on to the next question. If you have any issues with this, please send me an email. I'd be glad to give you a hand.